Hello and welcome to the third lesson on GCSE, IGCSE and GCE Mathematics. Today's lesson is about recurring decimals, Unit 3. Right, recurring decimals. What are recurring decimals is when we work out fractions, these fractions, now fractions are like this, for example, fractions means the numerator is divided by the denominator. Now, if the numerator is lesser than the denominator, we will have a decimal answer, 0 point something. Now when we say recurring decimal, what happens is when we divide the top by the bottom, the number of decimal places does not end but continuously occur on and on and on and on and on. That is recurring decimal. Right, now let's see for example the first question. Circle the fractions which can be written as recurring decimals. Right. Now, if you work out the first fraction, that is 2 over 3, or the 2/3, this fraction, if you work out, you will end up in an answer 0.666666 recurring. 6 will continue. So that is an example of a recurring decimal. Okay, so as it says, circle. Right, 3/4, if you work out, that will end up at 0.75. So that is not recurring. And 4/5, 4 over 5, you will get an answer of 0.8. So that's also not recurring. But if you work out 5 over 6, once again, you will get like 0.8333 recurring. So that is a recurring decimal as well. And 5 over 7 is the next one, which you work out. You will have some recurring numbers, 0.714 and so on. Next is 7 over 8. 7 over 8 is not a recurring decimal. The answer you will get is 0.875. So let's see the last one, 5 over 12. That is, once again, if you work it out, you will end up in a recurring decimal. Right, okay. So these are the examples of recurring decimals in this question. Right, okay. Let's go to the next question. Right, now in this question, what does it say? Write these numbers in order of size. Start with the smallest number. 0.573, everything. But the dot on top represents that, this is a recurring number. So the dots represent, those are recurring. For example, here, the first one, 0.573, they are the dots. 73 means 73 will be recurring. So it will be 0.5737373, like that. Okay, so if we, let's say, write it down. So let me just write it down for you. So this will be 5737373 and so on. Now here 0.5, the first 5, not the second in the middle, the 7 in the middle, but the third number, 3, that's also recurring, right? So in that case, what happens is here, the 5 and 3 are recurring. But although 5 and 3 are recurring, remember, the middle one is not given as a recurring number. Still, what happens is, since it is in the middle, that should be recurring. That means this will be 573 and 573 and so on. The third one, just 0.573, it's not a recurring answer. So that means the rest will be zeros. And the last one, you can see, only the last 3 is recurring. Right, so now we have written it down. Now it's easy for us to, figure out which one is the lowest. So out of all of these, 0.573 is the smallest one. And 0.573, 573,333, I think. So that's the second largest one, right? And sorry, let me get the pen. Okay, so this is the second largest one after that. And 5737, 5735 here. So this is the third one. And this is the largest number out of all of these 0. All are 0.573, but because which of the decimal place is recurring, based on that, we can say this is the lowest, this is the second, this is the third, and this is the fourth, right? Okay, I hope you understood that question. Right, let's move on to the next question now. Question number 3. Right, so this question says, prove algebraically that the recurring decimal 0.34 has the, now 4 means the dot is on the 4, so that means the last number, 1, there is one recurring number, has the value 31 over 90. Okay, what do they want you to show is that they want you to prove that this is equal to this. Right. At once it might, look kind of difficult, but believe me, this is very easy. Right? What you have to do is, now, first of all, you look at the number and see how many recurring decimals are here. Now, there is only one number which is recurring. So when one number is recurring, to this number you because they are saying algebraically. Algebra means using letters. So you take this number, substitute 0.34 to an algebraic number, maybe let's say x. So if 0.34 is x, next step is to see how many recurring places, and based on that, we multiply this by different numbers. So since there is only one decimal place, then remember, if there is only one decimal place, that means one recurring decimal actually, then you will have to multiply this by 10. So that means we take 10x. So when we take 10x, what happens? If x is 0.34, then 10x will be, when you multiply the decimal by 10, 3 would shift here, right? The one step, because multiplying by 10 means 1 0 place will be moved. So this will be 10x will be, if 1x is 0.34, then 10x will be 3, 4, like 4, 4, and like that. 4 is recurring. Then we take away 1x out of it. So 1x is 0.34. 1x is 0.3444 and all, and 10x is 3.14. So we take away 1x from 10x. So when we take away 1x, that means the remaining thing is equal to 9x. So what's equal to 9x? 4 minus 4 is 0, 4 minus 4 is 0, 4 minus 4 is 0, 4 minus 3 is 1, and 3. So 10x is equal to 3.444, 1x is equal to 0.34, and 9x is equal to 3.1. The next step we do is actually we times this. This is equal to 9x, right? So we times it by 10. So when we times it by 10, 3.1 times 10 is 31. And that is 3.1 is equal to 9x. So 9x times 10, it is equal to 90. So 31 over 90. As you can see, we have proven that. Okay, we have proved it. All right. Let's go to the next one. Question 4, once again, we need to prove algebraically 0.38 as 7 over 18. Right, you can pause this video and try this question, and later on you can check the methodology that I'm using. If you know maybe another method to solve, you can still try that, or you can actually replay the question number 3 and try to follow the same step and then solve it and check your answer. Okay. All right. I hope you paused the video and you tried the question and you got the correct answer. Right. Let me work out the way that I explained you earlier. So I'm going to take 10. Now here also there is only one recurring. So I'm going to take 10x, and from that I'm going to minus 1x, so that I will end up in 9x. Right. So if 1x is 0.38, then 10x is 3.8 recurring. And 1x is obviously 0.38 recurring. So now we know here 8 minus 8 is 0, 8 minus 8 is 0, 8 minus 8 is 0. 8 minus 3 is 5, and 3 minus 0 is 3. So we have here 3.5. All right. So 9x is equal to 3.5 here. Sorry, 9x is equal to 3.5. And that means, okay, so 3.5 times 10 next. And that is 35. And 9 times 10 will be 90. So 35 over 90. Of course, it's a large fraction. We can simplify. 35 divided by 5 is 7, and 9 divided by 5 is 18. So we have just proved that 0.38 recurring is equal to 7 over 18. All right, let's move on to the next question. Right, I'm pretty sure that you can use the same method that I explained to you and, do the rest of the questions, including this one, but it's fine. I'll explain you this question as well right away, because this is having 3 recurring numbers. Obviously, you see the dots are put on only 4 and 7, only 2 numbers. But remember, as I mentioned earlier, if, there are 2 numbers which are recurring and there is a number or 2 in the middle, that means the middle number also will recur along with the other 2. So here 4.13 is recurring. Now since 3 numbers are recurring, we have to, multiply this one actually by 1000. Multiply it by 1000 instead of 10 as we did earlier. Okay, so let's do it now. So first of all, 1x is equal to 0.417. So 1000x, there's 3 decimal places, so 3 zeros. 1000x will be 1, 2, 3 it will go to. So it will be 417.417, 417, and so on. And 1x is equal to 0.417, 417, etc. So 1000 minus 1 is 999. Right. 999x will be equal to, all of these will end up in zeros. 417.0, like that. Okay, so now what is that? 417 over 999. One is 417 over 999. Now, instead of multiplying, this time we can divide. We can divide both top and bottom by 3. 417 divided by 3 is 139. And 999 divided by 3 is 339. And once again, we have proved what they have asked us to prove. Right, now try question number 6 and then check the answer later on once you have done. So please pause the video and try the question number 6. Okay, so you must have tried and you must have got the correct answer. Let's see. Let's ensure that you are correct for sure. Right, okay. 0.318. 18 is recurring, to be written as 7 over 22. Now here, the last two numbers are recurring. So since two numbers are recurring, as I said, one number recurring means times by 10, two numbers means times by 100, three numbers means times by 1000, and so on. Okay. So 100x will be 1x is this. 100 means 2 steps it will go move from. So 100x will become 31.81818, because that's a recurring. Then minus 1x will be 0.31818, etc. Okay. So 99x in that case will be, sorry, 0.0008 minus 3 is 5, 1, 3, 31.5. 99x is 31.5. So we can just multiply by 10. So that will be 315 over 990. 315 over 990. Right. So 990 and 315 both can be divided by 45. Right, but I'm just going to go step by step for those who might find it difficult. Okay, when we divide 990, yeah, I think if we once again divide it by 10, it is going to be 3.15. So we can do is like divide it by 3. So 990 will become 330. And when we divide 315 by 3, it will become 105. Now we can divide by 5. 105 divided by 5 is 11. Sorry, 21. And 330 divided by 5, you will get 66. Now, both 21 and 66 can be divided by 3. 21 divided by 3 is 7, and 66 divided by 3 is 22. Obviously, you can straight away divide by 45 and arrive at this answer. But if you find it, difficult to think, okay, what's the number we can divide this one by? It's, no harm. It would take a little bit of time, but, it's no harm that simplifying it step by step like this. Okay. All right. Let's go to. Right. Look at question number 7. Using algebra, prove that 0.327 times 0.5 is equal to 2 over 11. right? 0.327 times 0.5 equals to this fraction. Okay, at once, even this looks like it's a bit hard, but it is not, believe me. What you have to do is you just use the same thing that we did earlier for this side as well as this side, first of all, and then you will get a fraction here, and then multiply the two fractions. Okay. Now here 0.327. Here 27 is recurring. So that means we need to multiply it by 100. 100x. This is for the first part, right? So when it goes 100x, when we times, the decimal place goes 2 levels. So 100x will be equal to 32.727, right? And 1x is 0.272, sorry, I'm sorry, 0.327. Right, so now what happens? 99x is 7 minus 7 is 0, 2 minus 2 is 0, so 7 minus 3 is 4, and 2 minus 0 is 2, and 3. So 32.4, 99x equals 32.4 here. So we times it by 10, so this will be 324 over 990 when we time by 10. Right. So now when we simplify this, 324, if you want, you can actually try to simplify step by step. Right. If you want, you can do it like step by step and to arrive at the simplest fraction. But actually, both 324 and 990 can be divided by 18. 324 divided by 18 is 18. And 990 divided by 18 is 55. Okay. So the simplest form of the first one in fraction form is 18 over 55. Let's work out the second one. 0.5 is recurring. So just one decimal place, which is recurring. So we times it by 10. So 10x is equal to 5.555. That's it. And 1x is equal to 0.555. So in that case, 9x is equal to what? These will cancel each other. So 9x is equal to 5.000, so on. Right, okay. So this one is what? 5 over 9. So now we have two fractions. The first decimal number, the fraction is 18.55. And for the second one, 0.5, the fraction is 5 over 9. So it is multiplied. So 18 over 55 multiplied by 5 over 9. That's the question. So let's work out this. Right. So when we work out this, we can also do like, instead of like, okay, one thing that you can do is write 18 times 5 and write it down on top, 55 times 9 and write it down on top in the bottom, and then it will be a big fraction and you need to simplify. Otherwise, we can just do it like this, 18, and we can work out with the what that means numerator of 1, we work out with the denominator of the other. Okay, 9 divided by 9 is 1. 18 divided by 9 is 2. And 5 divided by 5 is 1. 55 divided by 5 is 11. So now we have the most simplest form. 2 times 1 is 2. and 11 times 1 is 11. So if you can see, we have just proved that this answer will work out in fraction form 2 over 11. All right. Hey, question number 8. Whoa. What's happening here? All right. Looks very difficult. X is an integer such that it's greater than or equal to 1, less than or equal to 9. Show that 0.x as a decimal and x is recurring is equal to x over 9. Okay, once again, this is not difficult as it seems. Now, earlier we were given a number. Now it is given in form of an algebra. That's all. X is an integer. X is a number. It's a number between 1 and 9. So it can be any number. So they want you to show that 0.x recurring is equal to x over 9. You do the same thing. Now here if you see, the number of recurring decimal is 1. So then you must multiply by 10. So first you take 10x. What's 10x? If 1x is equal to 0.x, then 10x will be equal to, this will go to the other side. So x point x recurring. If 1x is equal to 0.x, 10x is equal to x point x recurring. So minus 1x. So 1x is equal to what? 0.x recurring. So when you take away 10x minus 1x is equal to 9x. So what is equal to 9x? All of these gets cancelled to each other. What remains is just an x. So 9x is equal to x. So the answer is x over 9. That's it. Right, question number 9. Y is a whole number such that y is greater than or equal to 1 and lesser than or equal to 9. Show that 0.3 y recurring is equal to y over 33. Okay, now here we have two recurring numbers. So we have to multiply it by, let me get the pen, right. So two recurring numbers, so we need to multiply it by 100. So we take 100x equals to what? If 1x equal to 0.35, then 100x will equal to 3y, because when you times it by 100, it will go 2 steps away. So it will be 3y point 3y, 3y, etc. Then 1x is equal to 0.3y, 3y, and so on. So 100 minus 1 is 99x. So 99x is equal to, these will end up in 0. 99x equals 3y. So 3y over 99. So both we can simplify by 3. 3y divided by 3 is just 1y. 99 divided by 3 is 33. As you can see, we just proved even that. Let's go to the next question. Question number 10. Rita says, I can tell from the denominators that 17 over 40 will convert into a terminating decimal. But 17 over 70 will be a recurring decimal. Right, now this is Rita's argument. So the question is, explain how Rita can tell from the denominators whether a fraction will convert into a terminating or a recurring decimal. Right. Now, how can you figure out whether something is a terminating decimal or recurring decimal from its denominators? Right. Okay. It is not hard to figure out. You know how you can figure out is you just look at the prime factors of the denominator. You see the prime factors of the denominator, and if both those prime factors, whatever, not one or not two, maybe there can be many prime factors. If all those prime factors can be, divide into 10, then that is a terminating decimal. If any of those prime factors cannot like end up in, divide 10, then it is a recurring decimal. Let me show what I'm saying. Okay, let's say, for example, the first one, the denominator is 40. And second one, denominator is 70. So what are the prime factors of this? 40, 10 times 4. 70 is 10 times 7. 10 can be divided, saying 10 is 2 times 5 and 4 is 2 times 2. So the prime factors of 40 is 2 and 5. 70, what are the prime factors? 2 times 5 is 10 and 7. So 2, 5, 7. Right. Now, 10. Can you divide 10 by 2? Yes. 10 divided by 2 is 5. Can you divide 10 by 5? Yes. 10 divided by 5 is 2. But can you divide 10 by 7? Obviously, you can, but you will end up in a decimal. So this is what you do. Looking at the denominator and see if the denominator has, its prime factors, if those factors can be divided into 10, then that is a decimal which will end up or terminate in a certain number. But if the prime factors in any of the fractions denominator cannot be divided into 10, then what happens is it will be a recurring decimal. It will not terminate at a certain point. It will continue to recur. Okay, so